All right, entire radicals and mixed radicals. So start with square roots. Complete the following statements. 7 times 7 is 49, so the square root of 49 is 7. Negative 7 times negative 7 is also positive 49, so another square root of 49 is also negative 7. The number 49 has two square roots, one positive, one negative. We call the positive square root the principal square root. So we'd say the square root of 49 is 7. The negative square root is called the secondary root, and we would say that's the negative square root of 49, which is negative 7. Note, every positive number has two square roots, a principal square root and a secondary square root. We get these secondary square roots. We have to keep track of those if we're solving an equation like this. If I said x squared equals 49, in order to solve for x, I take the square root of both sides. So x should equal the square root of 49, but if I just wrote it like that, that would just be considered the principal square root. So anytime you get rid of that exponent 2 by taking the square root, you have to include the positive and negative, because there's two possible roots. So x should equal plus or minus 7. So if you're solving a quadratic equation, a degree 2 equation, by taking the square root, you have to include both the positive and negative. If you just see something like this, what's the square root of 49? Well, that's 7. The plus and minus isn't in front of that. It's automatically understood to be positive. What's the negative square root of 49? Well, that's the negative value of 7. But if you actually have to solve by getting rid of that exponent 2 by taking the square root of both sides, then you must include this plus and minus. So there's always two square roots for every positive number. Every negative number does not have a square root. You can't take the square root of a negative number, not in the real number system. You think about it. Let's say I've got negative 36. Find two numbers that if I multiply the same value together, I'm going to get negative 36. Well, those two numbers can't be the same. If you try negative 6 times negative 6, you'll get positive 36. If you try positive 6 and positive 6, you get positive 36. So if these two numbers are the same, you will never ever get negative 36. Therefore, there is no square root of a negative number. The square roots of perfect squares are called rational numbers, right? So square roots of 36 are positive and negative 6. The square roots of non-perfect squares are called irrational numbers. There's no square root of 35 that's perfect, so we'd say the square root of 35 and the negative square root of 35. Those are called irrational numbers. Remember, irrational numbers go on forever. They never end. They're decimals that never end. They can't be put in fractional form, and they're non-terminating, non-repeating decimals. Cube roots. So let's look at what a cube root means. 3 times 3 times 3 is 27. Therefore, the cube root of 27 should be 3. Negative 3 times negative 3 times negative 3 should equal, that should be negative 27. Do you guys have negative 27 in your book? The cube root of negative 27 would be negative 3. Note, all numbers, whether they're positive or negative, will have only one cube root, denoted by the cube root symbol. All right. Unlike square roots, where you can't take the square of a negative, and every positive number has two possible squares, the positive and negative, cube roots, every cube root has, or every number has one cube root. All right. So the cube root of a perfect cube is a rational number. Cube root of 1,000 is 10. 10 is a rational number. The cube root of negative 8 is negative 2. Negative 2 is a rational number. But we can take the cube root of a non-perfect cube, like 49. There is no cube root of 49. That's a perfect number, so we would say that is a irrational number. There is no perfect cube of 49. So we can have irrational numbers that are cube roots, square roots. We could go to fourth roots and fifth roots as well. All right. So example 7, without using a calculator, evaluate where possible. What is the square root of 64? Well, because that's given to us, there's only one square root, and that's positive 8. What's the square root of negative 64? There isn't one. No square root. You can't take the square root of a negative number, right? 8 times 8 would give us 64. Negative 8 times negative 8 would give us positive 64. So no number multiplied by itself will ever give us a negative. The negative square root of 64 would be the negative of 8. Cube root of 64, you guys know what that is? 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. The cube root of negative 64, every number has a cube root. That's negative 4. Negative times itself 3 times gives you a negative. And the negative cube root of positive 64 would also be negative 4. So using your square root or cube root feature on our calculator, find the exact values. Cube root of 729. So if we get our calculator, let's figure out the cube root of 729. So if you hit your math button and you go down to number 4, we get the cube root of 729. That has a value of 9. Square root of 196. Square root of 196 has a value of 14. And the cube root of 512 over 343. Cube root of 512 divided by 343. And because that's given as a fraction, let's answer. Hit your math fraction button. Answer as a fraction. That'll be 8/7. So what that means is the cube root of 512 is 8. The cube root of 343 is 7. Those all have exact values, so you would say these are all rational numbers. If we look at part 3, example 3, part A, evaluate to the nearest hundredth, the square root of 52, that one does not have a perfect square root. Oh yeah. The square root of 52 is 7.21102551. It wants it to the nearest hundredth, that's 2 decimals, 7.21. And then the cube root of 71. Cube root of 71 would be 4.14 to the nearest hundredth. So when we start dealing with non-perfect square roots and non-perfect cube roots, we get into things called radicals. All right? So these are both examples of radicals. Non-perfect squares, non-perfect cubes. A radical consists of 3 parts: the radical symbol, the index number, and the radicand as illustrated below. So this whole thing is called a radical. All right? Here's our index number. We've got the radical symbol, and the number inside the radical sign is called our radicand. Note, when the index number is not written, it's always understood to be 2. That's the most common, right? Square root or second root. So example 4, identify the index and the radicand in each of the following. So part A, the index is 3. The radicand is inside the radical symbol, 1, 2, 3. Part B, the index number is not written, so it's understood to be 2. The radicand is 77. And in part C, the index number is 3. The radicand is negative 1/2. All right? So understanding parts of a radical. Combining radicals. So use your calculator to do the following calculations and complete the following statements by writing is equal to or is not equal to in the space provided. Well, I don't even think we need our calculators too much. We might a little bit. Let's try it. What's the square root of 25? 5. And the square root of 16 is 4. So we know 5 times 4 gives us 20. So this value is 20. 25 times 16 underneath the radical sign. 25 times 16 is 400. If I take the square root of 400, I also get 20. So this is like saying the square root of 400, which also equals 20. So both these things are equal, so we would say equal. Square root of 25 divided by the square root of 16. Well, square root of 25 is 5 divided by the square root of 16, which is 4. So 5 divided by 4 is 1.25, 5 quarters. The square root of 25/16 then, we actually just have to do that with our calculators. The square root of 25 divided by 16 will give us 1.25. So that's also 1.25. So we would say that these are also equal. You guys try the second and third examples here and then see what we get. So square root of 25 is 5, square root of 16 is 4, 5 plus 4 is 9. 25 plus 16 is 41, so square root of 41 is 6.4. These are not equal. And if we look at the subtraction, 5 minus 4 is 1. 25 minus 16 is 9. The square root of 9 is 3. So 1 does not equal 3. So these are not equal. All right. So the calculations above are examples of some general rules involving radicals. The product or quotient of the roots of two numbers is equal to the root of the product or quotient of those two numbers. In other words, what it's saying is square root x times square root y is the same as saying square root x times y. Or you can do the quotients. Radical x over radical y is the same as saying the square root of x divided by y. That's what this statement says. Part 2 says the sum or difference of the roots of two numbers is not equal to the sum or difference of the two numbers. The root of the sum or difference of the two numbers. So it only works for multiplying and dividing. So state whether each of the following is true or false. Radical 6 times radical 3 is radical 18. Yes, that's a true statement. From above, that's exactly what it says. However, the square root of the sum of two numbers is not the same as the sum of two square roots, so this is false. But the division of two radicals is the same as dividing them first. So we could say that's the same as the square root of 60 over 6, which is where radical 10 comes from. So this is true. All right. So I'd like you guys to try questions 1 through 4. Every one of them. Away you go. Let's have a look at entire radicals and mixed radicals. Use a calculator to approximate the value of each radical to 5 decimal places. So grab your calculator and do that to 5 decimal places. Write them in. There you go. You haven't got a calculator? All right, so here's what you should notice. Square root of 48, 2 root 12, and 4 root 3 all give you the same values of 6.92820. All right, so all of these give us 6.92820. What do you know about the answers? Well, we should say they're all the same. Same values. use the rule x squared xy equals radical x times radical y to complete the following, which explains why the three radicals are equivalent. Radical 48, well, 48 can be written as 4 times 12. And if I now use this rule, square root of 4 times square root of 12. And we know what the square root of 4 is. That's 2 square root 12. So radical 48 is the same as 2 radical 12. Yep, they got the same value up there. 48 also can be written as 16 times 3. So using this rule, I would say the square root of 16 is 4, and the square root of 3, oh, I lied. I would rewrite this as square root 16 times square root 3. And we know the square root of 16 is 4. There is no square root of 3. So now, radical 48 is the same as 4 radical 3. So what we've learned, radical 48 is an example of an entire radical. Everything is underneath the radical symbol. There's only a radicand. The number in front of the radical sign is 1, but it's usually not written, so it's understood to be there. 2 radical 24 and 4 radical 6, they're both examples of mixed radicals. They've got a number out front of the radical sign, so we call those mixed radicals. So by definition, an entire radical is a radical expressed in the form the nth root of b, where there is a number multiplied to the radical, but that number is always 1. And it's usually not written in front. All right. Mixed radicals are expressed in the form a times the nth root of b. They've got a numerical value multiplied to the radicand, 2 multiplied to the radical, 2 radical 7, 3 cube root 3, and negative 4 square root 5. All right, so now we know what an entire radical is. We know what a mixed radical is. We're going to skip ahead a few pages. Let's go to page 276. And we're going to convert mixed radicals to entire. So every single mixed radical can be expressed as an entire radical. So a mixed radical of index 2 may be expressed as an entire radical by converting the number outside the radical symbol into a radicand and then multiplying it by the radicand. The number outside the radical symbol can be converted into a radical by raising it to the power of 2 if the index number is 2. So complete the following to convert 4 radical 5 to an entire radical. We're going to start with the mixed radical 4 radical 5. In order to bring the number 4 inside the radical sign, we would square it, because the index number is understood to be 2. So to bring it inside the radical sign, we must square it. So 4 squared is 16. We can now use our rule. The square root of 4 squared times the square root of 5 can be written as the square root of 16 times 5. And the square root of 16 times 5 is 80. So mixed radical 4 root 5 is the same as entire radical 80. So pretty straightforward to convert from mixed to entire. Convert the following mixed radicals to entire radicals. So 2 radical 6 can be written as an entire radical if I bring the 2 in front, take the 2 from in front and put it inside the radical sign by squaring it. So 2 squared times what's already inside the radical sign, which was 6. So 2 squared is 4. 4 times 6 is 24. You guys try B. All right, if you took the 5 inside and squared it, negative 5 squared is 25 times 7 is 175. And you guys said that was a negative. But you're squaring a negative, so that should be a positive. Is that what you guys answered? Radical 175? Now look at the original question. Negative 5 times radical 7. What's the sign going to be if I multiply this out of my calculator? That's going to be a negative value, isn't it? All right? The negative of 5 times the square root of 7. That's going to give you a negative value. If you look at this one, square root of 175, that's not going to be a negative value. So what you have to do is keep the negative sign out front, and then you can bring the 5 squared inside. So you will get radical 175, but that negative sign has to stay out front of that radical. Because the original question will be negative, we can't change the value. We just want to change the way it looks. No, if you do it with your calculator, you should get the real answer. Let's try it. Negative 5 times the square root of 7 will give me a negative value. And if we try the square root of 175, we're going to get a positive value. So those have to be equal. In order to make these equal, this better have a negative sign in front of it. So it should be negative radical 175. All right? And if we look at part C, to make this into an entire radical, we're going to keep the radical 18 there. We're going to multiply it by 2/3 all squared. So if we're really good with fractions like I know we are, 2 squared is 4 and 3 squared is 9. Multiply that by 18. So you can go 4 times 18 divided by 9, or you can say 18 divided by 9, which is 2, and 2 times 4 is 8. So C would also be written as radical 8. Now let's do an application of mixed radicals. If you're asked to order mixed radicals, a set of mixed radicals can be placed in numerical order from least to greatest or greatest to least if you convert them to entire radicals. All right. So if I looked right now, without using a calculator, arrange the following from greatest to least. If I just looked at these right now, it'd be really tough to do. Without using my calculator, which is the largest value there? Well, it's hard to say. But if I convert these all into entire radicals, then we're going to see what's largest and smallest real quick. So 3 radical 5 can be written as 3 squared times 5. So 3 squared is 9 times 5, so this would be radical 45. Part B, that can be written as a square root of 5 squared times 3. 5 squared is 25. 25 times 3 is 75. Part C is already radical 15. D could be written as the square root of 6 squared times 2. 6 squared is 36. 36 times 2 is 72. And D could be written as the square root of 2 squared times 6. 2 squared is 4. 4 times 6 is 24. Well, now we can see it's very, very easy to identify the largest value here. The largest value is going to be radical 75. So if I order these, it's going to be 5 radical 3, which is the same value as radical 75. And then radical 72, which is 6 radical 2. And then we've got radical 45, which is 3 radical 5. And then I've got radical 24, which is 2 radical 6. And finally, radical 15 is the smallest value. So if you convert these all into entire radicals, then you look at the radicands, we're simply ordering numbers. All right. So now try questions 8 through 12. All right, let's jump back now to page 274, and let's look at converting entire radicals to mixed radicals. An entire radical of index 2 may be expressed as a mixed radical when the highest perfect square has been factored out of the entire radical. So over here we have a list of all the perfect squares. 1 squared, 2 squared, 3 squared, and so on. So complete the following to convert radical 20 into a mixed radical. So the entire radical is radical 20. Make it a mixed radical. So we can say 20 is, well, the highest factor of 20. Highest factor of 20, that's a perfect square, is 4. So you'd say 4 times 5 is 20. Using our rules, we know that radical 4 times radical 5 is the same as the square root of 4 times 5. And we know that the square root of 4 is 2. So that's like saying 2 radical 5. So radical 20 is the same as 2 radical 5. So we've converted from an entire to a mixed radical. Using perfect squares, that are factors of our radicand. All right. Jake and Chanel have been asked to convert radical 72 into a mixed radical. Jake recognized that the highest perfect square, which is a factor of 72, is 36. So he wrote his work as radical 72 equals radical 36 times radical 2. The square root of 36 is 6, and there is no square root of 2, so it stays as radical 2. Chanel thought that the highest perfect square was 4, so complete her work. So 4 times 18 is definitely 72. The square root of 4 is 2, so you've got 2 radical 18. But then she recognized that 18 can be written as radical 9 times radical 2. And the square root of 9 is 3. So 2 times 3 is 6, and there is no perfect square of 2, so it's also 6 radical 2. Which way would have been easiest? Well, if you recognize, like Jake, that the highest perfect square of 72 is 36, much simpler question. But as long as you keep going until you can't find a factor of the radicand that's a perfect square, you're going to get down to the right answer. So question 7, convert the following radicals to mixed radicals in simplest form. Radical 160. Well, you look for a factor of 160 that's a perfect square. That would be 16 times 10. So I would rewrite radical 160 as radical 16 times radical 10. The square root of 16 is 4. There is no square root of 10. Now I've already got the 3 out front, so I'm just going to work with radical 98. And the highest factor of 98, that's a perfect square, is 49. So I'd write this as radical 49 times radical 2. So the square root of 49 is 7. There is no square root of 2. So I've got 3 times 7 radical 2. Well, 3 times 7 is 21. So that's 21 radical 2. An application of this would be using Pythagorean Theorem or the distance formula. Consider line segment AB on the grid. Determine the exact length of this line segment in simplest mixed radical form using Pythagoras' theorem. So if I use Pythagorean theorem, I will have to make this into a right angle triangle. So that is now a right angle triangle. I know this height is 1, 2, 3. I know this distance is 1, 2, 3, 4, 5, 6, 7, 8, 9. So using Pythagoras' theorem, I don't know what the hypotenuse is, but I know one side is 3 and the other side is 9. So c squared would equal 9 plus 81, or c squared is 90. Take the square root of both sides, and c would equal radical 90, which could be written as the square root of 9 times the square root of 10. So c would equal 3 radical 10 in simplest radical form. Now if I use the distance formula, I'm just going to plug in the points. I would say point A has coordinates x1, y1, and point B has coordinates x2, y2, and I'm just going to substitute these into my distance formula. So the distance from point A to point B would equal the square root of x2, which I identified as 3, minus x1, which I identified as negative 6, and that should be squared. Add y2, I said that value is 1, minus y1, which is negative 2, all squared. So the distance from point A to point B would be the square root of 3 minus negative 6, a lot like saying 3 plus 6, which is 9 squared, and 1 minus negative 2 is the same as saying 1 plus 2, which is 3 squared. So you've got the square root of 81 plus 9, which is the square root of 90, which we already simplified up here as 3 radical 10. So both ways we get the same answer. All right. Let's jump ahead to page 277 and look at an extension, entire radicals and mixed radicals with index numbers of 3. So off to the side now we've got all the perfect cubes, 1 cubed, 2 cubed, 3 cubed, and so on. An entire radical of index 3 may be expressed as a mixed radical when the highest perfect cube has been factored out of the entire radical. So complete the following to convert cube root 40 to a mixed radical. So I look at cube root 40 and I try and find a factor of 40 that's a perfect cube. That factor is 8. So 8 times 5 gives me 40. Using my rules, I can say the cube root of 8 times the cube root of 5 is the same thing. And cube root of 8 is indeed 2. So cube root 40 can be written as 2 times the cube root of 5. So I've changed an entire radical into a mixed radical by factoring with the largest perfect cube of the radicand. So a mixed radical of index 3 may also be expressed as an entire radical by converting the number outside the radical symbol into a radical and then multiplying it by the radicand. The number outside the radical symbol can be converted into a radical by raising it to the power of 3 because the index number was 3. So change 4 cube root 9 into an entire radical. Well, to bring the 4 inside the radical sign, I must cube it. And 4 cubed is 64. And 64 times 9 is a rather large number. 576. So this becomes the cube root of 576. All right. There's examples. You guys can now complete every question in this section. Away you go.